So here is the similar triangles notes. Okay, similar triangles. We're going to get down with that. First thing, we always got to put our name on everything, and today it's going to be that one guy. So similar triangles, and today's that scary February 13th, Friday the 13th. Ooh. Thank you, sir. Thank you, sir. Because it's the 7th, 5th day. Now, figures that have the same shape, but not necessarily the same size. So a triangle that is the exact same shape, let's say it's an isosceles triangle, and then there's one that's like a miniature version of it, okay, like a miniature version. It's going to be not the exact same. It's going to be called similar. It's going to be called similar. It is a similar. It is similar. Quiet, please. It is similar. Now, don't write this until I say to write it. The symbol that means similar is something close to what we did yesterday, but what's that symbol? That's congruent. This is actually a symbol for similar. It's just that top tilde.
And the dot? Looks like an eye.
Good question. Yeah, it was just the cursor. Give us that's a symbol for similar to. It's just the tilde at the top of the equal sign above what you find in an enye, or just tilde end of time. Okay. If two congruent triangles are similar, then they're corresponding. Nick, what's corresponding again? You asked that at Moto last night, right? Okay. Corresponding is the same spot. It's the same spot on a different shape or angle. Like the transversal. The corresponding for the transversal, to go back in time, there's Thursday, there's Wednesday. Nope, there's Thursday. There's Wednesday. The transversal, the angle 3 and angle 7, those are corresponding spots. They're the lower right of that transversal that goes through parallel lines. Okay? The 2 and the 6, the angle 2 and angle 6, those are corresponding spots. We had that a couple days ago.
Wait, what was the one about the corresponding angles?
No, stick with me, please. They're congruent. They are congruent. And it's just the angles, by the way, not the sides, the angles. What's that? Well, you can do both.
Because in 30 years, maybe you won't remember what that sign means. You look at your notes, you're like, you know what? It was Friday the 13th because it's bad luck that I didn't write the word.
Exactly. I believe you make your own luck. Some unlucky things might happen to you, but you gotta make your own. If the two triangles are similar, then their corresponding sides are just proportional. Proportional. And we've done proportions many, many times. Proportional. Here we have two triangles, and we're going to label them triangle G, HI, and triangle JK, L. And I will tell you that these two triangles are similar. We have triangle GHI is similar to JKL. Because I'm going to keep the sides going as far as the same thing. We started here, went down to GH, and then we went there to I. So I started at J, went down to K, went over to L. Did the instructions on that part make sense? Okay, yep, you're doing all right. Yes?
So, this is, do you think that when unicorns see the Skittles commercial...
Does it have to do with this? I'm going to stop you right there. Does that have to do with similar triangles?
The unicorns are rainbow.
That has nothing to do with what we're doing, so I'm going to stop talking to you about that. No.
I wonder if I fly in the sky, if my rainbows...
We're going to write a proportion for that. I'm going to write a proportion for that. For these next two, I'm going to show you what the proportion looked like with those side lengths. Now, with these similar triangles, we have 3 bits of information and 1 spot that we don't know. You've seen a couple of these questions on your snapshots, and we haven't done so well on these. By the way, if you want, we can look at the snapshots, and I can show you which answers you got wrong and the answers you got correct. Okay? You don't have access to that. I do. So we're going to write a proportion. We've had proportions many times during the school year. You already done? That was a really, really fast test if you're done.
Are these like fractions?
I would recommend doing only odds like that because it's easier to see when you need to simplify when you use a fraction. Is that right? Did you hear what I just said? All I'm going to say is it's easier to see to reduce if you have it as fraction form. Okay. We're going to write a proportion. The measure of of side GH, the measure of angle, measure of side GH. Yes, sir, please. So we have the side measure GH. We just took care of this one. Now, so this is like the mama triangle and this is like the baby triangle. Which side is the corresponding side of the baby triangle? AJ? JK. So these guys here. So the measure of side GH is going to be proportionate to the measure of side JK. It's the measure, yeah, measure of side JK. This is writing down all of it. You will not have to do it like that on the homework, but when you're looking back at your notes. So we have measure of JH, side GH is proportionate to side GK. Now we have to look at this guy. And please change this to centimeters, by the way. Change that to centimeters. That's a typo. Here's the corresponding angle for that guy. So we have HI, and the corresponding side is KL. So we have measure of side HI is proportionate to the measure, the length of KL. So we have GH, JK, high, and KL. Now let's substitute. Please stop shouting out. Substitute those in there. I'm going to do it as well, but don't look up here until you have tried. No, we're just substituting in for the information that we have. So the measure of GH, you're going to put that number in there. And if you don't know where I got those numbers from, I will show you. And if you do know where I got those numbers from, you are off to a great start. But if not, that's okay. I'll help you. Caleb. No, you will not have to set it up like that. Save yourself. So we have a proportion here. I'm going to show you where we got these numbers from. We have the measure. I'll use the highlighters. We have the measure of GH. Here's the measure of GH, 12 centimeters. It's in the top left of the proportion, so that's where it ended up. Okay? Then we have the measure of JK here is 4 because the measure of JK is right there. And more, we have the measure of HI. The measure of HI is 9 centimeters, so it goes in the upper right because that's where it is in that proportion. I guess I could do this. So I'm going to do a line right there so you can see that that's not. And then finally, what color haven't I used? Then finally we have, I use that one, magenta. The measure of X is the measure of KL because we don't know that. That's the unknown. That is the unknown. A to the J? No, because you're jumping way ahead of me. Jumping way ahead of me. Actually, I'm going to do this. There. What color was I using? Magenta. So we have, that's X, and this one was 9. 9. Okay. Now we're going to find the cross products. This is how you solve. This is how you solve for the variable that you don't know. We've done this with proportions of percentages. We've done this proportions of, let's see, what else have we done with this? Finding the missing, oh boy, how many other different applications have we used with this? We've used proportions for so many things. The cross products is the way that you find out what the missing spot is. So we do 12 over 4, 9 over x, and the cross product we're going to take is going to multiply these two by those two. I'm going step by step. I don't want the answer yet. So once I do the cross product, I come out to be 12x equals 9 times 4, which is, everyone? 36, good. So now I'm going to solve the equation. And if you want to review on solving equations like this, you can look at my YouTube, because that's what 6th graders are doing right now. Okay? Yep. We are solving equations using multiplication, division, addition, and subtraction. So now I need to solve the equation. In order to solve an equation like this, what do I have to do, Sydney? That's too specific right now. You're correct, but what do we have to do whenever I'm solving an equation, AJ? Oh, actually, Tony.
X by itself.
X by itself, yep. And I'm going to use inverse operations. What's happening to x, Sophia? What's happening to x? Eventually, it will be by itself, but right now something's happening to it. What's happening to x? It's what? Nope, no vacation. Something's happening to it right now. If you were to say this out loud, what would you say? 12x, true, but what does that represent? Is there something that's we know because we know algebra that's in here? 12 times x. So 12, it would be safe to say, this I was trying to get out of you, 12 is being multiplied by x. Okay? That's what's happening to x. And what's the inverse of multiplication? Sammy, do you remember? Division. Yes. So since 12 is being multiplied by x, I need to use inverse operations to get it to go away because variables are asocial. They don't like, you can set it right there. Yeah. And we have to do it to both sides because of this equal sign here. So that comes out to be 3. And not just 3, because what's our unit that we're dealing with here? 3 centimeters. So we just solved for a similar triangle using proportions. That. Yes, sir. Yes, sir. Thank you. All right. Good. Do we have any questions on that one before we move into something that looks different? Okay. All right, let's do one that's going to be more likely, because these two here, they're so pretty. They're sitting the same direction. They're sitting right next to each other. Okay. Then we have ones like this. These are also similar triangles, but they're not as nice. I mean, if it was going to be nicer, they would be sitting right next to each other, where maybe if we wanted to go at this angle here, and then there'd be another one smaller like that. But instead, what's happening is they're sharing a point, and this side's going whoop and rolling up there, and that kind of looks cool. Okay. But we have things that show us what the corresponding angles and sides are, don't we? How do we know what sides are similar? Yeah.
One of them has a right angle and the other one has a right angle on it.
One of them has a right angle and the other one has a right angle on it. Good.
And
Well, hold on.
Another one has the two, what do they call it? They have like the two,
Arcs.
yeah, the arcs.
Mhm.
It's, O.
Yep, point O. Angle O. It's not just angle O, but since they share a point, if you were going to talk about O with respect to this triangle, so O with respect to this triangle here, or O with respect to this triangle here, what you want to do is you want to indicate and make sure that you know which one is which. So if I was talking about this angle, it would be angle LO, okay? And if I was talking about this angle, it would be angle MON, okay? Just to let you guys know, remember the vertex is the middle one. That's for side information. Okay, so I'm going to tell you that these two are similar triangles, and the way that I'm going to show you that and tell you that is triangle KLO is similar. I'm going to pull that up. Triangle KLO is similar. Now, I want to keep this easier to look at later. So I want to have the corresponding angles be in the same order when I'm showing their similarness, how their similarities. Since I started with K, and that has one arc, what should I use for my first letter in my other triangle? Tyler? M. Yep, M, because this is also one, because those are the corresponding angles. Those angles are going to be the same. So triangle K. Then L is the right angle, so I'm going to use M. Then we have the point O. Anyway, the point O. Questions? Yes?
Shouldn't it be minnow? Yeah, the second one.
Oh, I'm sorry. Thank you. MN. Oh, wow. I really messed that up. Jeez.
oh, so was the answer to it 3?
It sure was. 3 centimeters. 3 centimeters. All right, now let's write a proportion here. I'm going to back out a bit so you can see both.
Homework, are you gonna have to write?
We're worried about this. Yes, you will have to write a proportion, but like the second one we did. All right, we're going to write a proportion for this one. We have similar sides here, and I'm going to identify those. We have the small side that's right next to the 90-degree angle. So what side is the corresponding side for NO? AJ?
That would be
LO, exactly. because it has one side with the right angle, and I can see that. This side has one side or corner with the right angle. Then we have two arcs in that angle, two arcs in that angle, so we can know that those are going to be the correct ones. What color am I using? Use blue. And then the other corresponding angle is going to be, we have an amount here, which is 10 meters, and we have an amount here, which is 5 meters. So those are going to be corresponding as well, right? Yes? Okay, so I'm going to write the proportion with the measure of the descriptions. So the measure of this guy is going to be proportionate to the measure of that guy.
Proportion going to look like 1 over x equals 3 over 4, for example. Is that what the proportion is like? Not.
It could. Yeah, it could. Yeah. So the measure of KO is proportionate to the measure of MO. Because we got the big one on the top, small one on the bottom. Then we had the measure of NO, and you will not have to do what we're doing right now in the homework, by the way, guys. Okay, you will not have to do it like that. This is just for the intro. And the measure of LO, line L, side LO. Yes.
On both sides of the difference, right? That is K or M? Up.
Up. We were doing NO and LO. It's an N. N is a nobody. NO-LO. So we got the small sides that are proportionate to each other. We've got the large sides that are proportionate to each other. Ew. There we go. So pretty. Stick with me, though, okay? So let's put in this portion. Yeah, let's substitute in the things we know. We have the big one at the top. Measure angle KO is what, Sophia?
Measure KO is
10 meters. 10 meters. And then the measure of, what is that? MO is what, Gwen? Okay, it is the measure of MO is 5 meters. Good. And then the measure of NO is what, Luke? As in nobody owns. Nobody owns is 3. NO. Did I have that backwards? NO is proportionate to LO. I want to switch these around. I want to switch those around because what I did is I had the large triangle on the numerator here, and then I accidentally put the small triangle in the numerator here, and that's not going to work. We wouldn't get the right one. So I'm going to move this down. Then we have the measurement of LO, which is going to be on top that I just switched, and that's just going to be U meters and 3 meters. To explain better what I just did, you need to have the bigger one stay on the top and the smaller one stay on the bottom in the denominator to keep it proportionate.
Could you do 10 over x and then 5 over 30?
Yeah. Because, yeah. Yes, sir. Yes. So we find the cross products. I'm going to rewrite this proportion. I'm going to zoom in. 10 over 5 equals U over 3. Cross products. Multiplying those together puts me at 30 equals 5u. Then I'm going to solve for that. And this is all stuff we've done before, that part. No, the only thing that you're going to have to do on the homework is just the steps that you can see visible right here.
Wait, so are you going to have to do this thing with the circles around the numbers?
Yes. Yes. That will be showing your work.
Is there a lot?
No. That's very few. It's 8. You'll do this 8 times. Okay? Any questions on that? To summarize, we just found our unknown. We kept it proportionate. We knew 3 of the sides. We didn't know 1 of them. We set up our proportion properly, and we got it. Now this one here, as I showed you at the beginning of class, the numbers were way off. So we're going to change a couple of these numbers. And how many of you have seen this image before on like a standardized test or snapshot or something? Yeah. You're going to see this guaranteed on the park test. And if it's not on there, I will stop traveling to Spain on the summers, okay? No, I don't go to Spain. Nope. I've been barely out of the country. Only been to Mexico twice. 3 times? Twice. Now, we're going to change her height to 5 feet. Okay, we're going to change her height to 5 feet. And also change the length of her shadow to 8 feet. Yes, sir. No, class is out in 4 minutes, so just hold it. Unless it's an emergency and go. Yes? Question? No. Okay, so we're going to set this one up. We're going to set this one up. We have 2 triangles in here, and I need to go quick because I just realized we only have 5 minutes. We have 2 triangles in here, and you can't really see this beam of light, so go ahead and draw a line there that goes from the top of the tree to the top of her head to the corner. Then we have this going straight up there, so make sure you have that one in there as well. So these triangles are going to be similar. I'm just telling you that. We have a big triangle, and then there's a littler one inside of it. When you have the same angles at the beginning and the 90, they're going to be similar triangles. So to set this one up, I'm going to have the tree be in the numerator, and I'm going to have the girl be in the denominator. So what is the height of the tree? Yes? X. We don't know. What is the height of the girl? 5 feet. So we have X feet and 5 feet. Now, the shadow of the tree, because we're going in the numerator, the shadow of the tree is how big, Gina? 125 feet. Then the length of the shadow of the girl is what, Juliet? 8 feet. Okay. Then the next question asks us to do the cross multiplication, or cross product rather. Yes, sir. 125 times 5 and x times 8. So we have 8x equals 125 times 5, and since we can't use calculators, I'm going to work this out right here. 625. Now I have to solve for the variable, and I'm going to use the inverse operation, so I'm going to divide it by 8. So 8, 6, 2, 5, 62 almost, 4, 5, almost 8. Okay, I'll just go there, 0. I'm going to stop right there. So 78.1 feet. That is how tall that tree is. 78.1 feet tall. I know I kind of rushed through that one, but the main idea is whenever you have triangles that are coming together, when one is inside the other, it's going to be similar triangles. Can you click the button, the green button there for WizTeach? So it looks like a little hat on a green. Then hit stop. Nope, stop.